Where's that word? Okay, so with all of these, we have to do a flowchart or pseudocode. Sorry about that. So you're getting the idea now that we have to do that. We do have to do a flowchart or pseudocode. We've done apparently last week. We did this this thing with the students. Some of the students, apparently we did exercise 1 and exercise 2, but we haven't done exercise 3 and 4, which is this average age thing. So the average age thing, how this program is working, we've got a group of people. We don't know how many in the group. So we have to ask the user how many in the group. And then we have to ask for the age of each member, and then we'll display the age. And you know what? And then at the end of that, we're going to take that program. So we might as well just we could save time by just doing the modification straight up, right? We're going to take the exercise 3, and we're going to test to see if each member is an adult, where an adult is defined as somebody who's 18 years or older. And so that means that we'll have to, at the start, we'll have to have a count for the number of adults. And then we're going to have to increment that count. But we'll only increment that count if the age is more than 18. So that means we're going to have an if statement. And that's going to be inside a while statement. So we're going to have a while statement. The while statement is going to be controlled by a count. The maximum count will be given at the start. And then there'll be an if statement that controls how many adults. So I think that's pretty straightforward, but let's just have a look at it, how it's going to look in a flow chart. So to do flow charts, we've been doing this a lot, so we're all familiar with this, I think. Just go to diagrams.net and start ourselves a flow chart. This one, what are we going to call this? This is lab 10. Let's say exercise 4. We'll just do exercise 4, I think, straight off of exercise 3, because they're basically, exercise 3 is included in exercise 4. So that's fine. And of course it's kind of better with the grid, right? Okay, so I'm going to start with our start. Now, just a good idea might make it easier for you to do this in the future. Just imagine that you had a module at the start of your program where you do all your initialization. That is, anything that you're going to have any totals or anything like that, just get it started right off the bat. And so we know we've got sort of 3 totals that we need to work with. So I'm just going to start them right now. So we're going to have a total for the average, which is the total ages or something. And that's going to be 0. So that's initializing that. We're going to have a count for the loop. And so that's going to have to be 0. And then we're going to have how many are adults. And so that'll have to be 0. So we know we're going to have those. So it's probably easiest just to start off straight away with initializing all 3 of those. So then once we've got those initialized, remember the way we like to work with our while loops is the while loop is controlled by something. We see that this while loop is controlled by a count. And so the count, we've set that before we go, but we have to know what is the maximum of that count. We could do that in the condition, but in this case, we actually have to get the maximum from the user. So maybe we need a get there. Come on. So this is where we could get the number. What does it say? Please enter number of people in the group. So get group size or something like that. So that's an input that we're asking users. And now we're ready to do our loop. And so our loop is going to be, we're going to know how many of these we're going to do. And then we're going to see if it's an adult. And yeah, that's basically it. All right, so let's go. So the next thing is going to be our condition to start our loop. And the loop is going to go as long as the, yeah, so while the count is less than the group size. Because the group size is the thing that controls this loop. So when the count gets to be as big as the group size, then we stop the loop. So we know that the true version of this is staying inside the loop. So what are we going to do inside the loop? Well, the first thing we're going to do is we're going to test to see if they are an adult or not. So we see that we're going to test to see if they're an adult. So we can that would have to be another, it's a test, right? And so this is where we test to see if they're adult, which is where the, oh, well, before we can do that, we actually have to get their name. Sorry, their age. I'm sorry. So let's undo that. Get their age. So the first thing we do is actually get the details of that person. So get the age. I don't think we have any other details. We don't get their name or anything like that. We just get their age. And then from that, we can check to see if they're an adult or not. And so we see if the age is bigger than or equal to 18. Now, if it is bigger than or equal to 18, so we can have a yes and a no here, right? Let's put the yes out here for a change. I'm just trying to think of how to make this diagram work, right? Where are we going to put things, left, right, or down? Well, we could try it down. This is, yeah, all right, we're just going to go down. So if they're more than 18, then what we're going to do is we're going to add 1 to the adult count. So the only way we add 1 to the adult count is if they're bigger than 18. So we should, that's true. If they're bigger than 18, then we add 1 to the adult count. Again, this one here is, this is true. We go down here if it's true. So if the count is less than the group size, then we go and get the age. So we add 1 to the adult count. If that's true, the next thing we're going to do is we're going to just add 1 to the count. Count is going to be incremented. Oh, we should increment the we need to increment the total. So total ages, total of the ages is going to be equal to the ages, the total ages plus the age, because we got their age there. What you're going to notice is that this is going to happen regardless of whether or not their age was bigger than 18. So what we're going to see is we're going to see an arrow come out from this, just go straight down to there. So we got kind of like a little diversion. Actually, I think I'll make that come out this way. So get an arrow. So what that's saying, and this is going to be the false. So if they're bigger than 18, we add 1 to the adult count. If they're not bigger than 18, we just go and add their age to the total count. And if they are, and we always add their age to the total count anyways. So we got both arrows coming out of there. Now what happens if the, so we need one more thing here, which is the, we need to increment the count. Now remember, in a counted loop, the count is controlling the loop. And so it should be the last thing in the loop. So as we're doing this, we're thinking, this is the last thing in the loop. I won't be putting anything else in this loop. And so I'll probably, and we know that how loops work is that you have an arrow going backwards. The only time you have an arrow going backwards is when you have a loop. This is a loop. And so we're going to have an arrow going backwards from the count. The count is the thing that's controlling the loop. So that's going to go back to the start of the loop. And the start of the loop was with that condition. So that's why I'm doing that like that. So that's basically saying, yeah, once you get to here, we go back here and we test the group size. And if the group size is not less than the count, then we are done that and we get to calculate the average. Yeah. So that's going to be here. Calculate the average. The average is going to be equal to, like always, it's the total of the ages divided by the count. I mean, average always works the same. It's always the same calculation, right? Total divided by count. We got our average. There's only one thing left to do, and that's all of our outputs. And so we can put an output there. That's going to be, we're going to print. We can see that here. We're going to print the average and we're going to print the number of adults. So that's it. I think that's a good enough representation of what our program's doing. Let's just go through and make sure we haven't left anything out. We got the start. We're initializing our variables here. Then we get the group size, how many we're going to have. If our count is less than the group size, and our count starts off as 0, so this is going to be true. Then we're going to get an age. Now, if that age is bigger than 18, we're going to missing something. Well, that's not good. So it's a good thing we went back and checked, right? If the age is bigger than, see, this shows it in both cases, it's going to do the same thing. Here, it's just going to skip the, oh, that's right. Yeah. If it's bigger than 18, we skip the adult count. I'm sorry, that is correct. But if it's not, if the age is bigger than 18, we add to the adult count. Otherwise, we skip the adult count. We just do and calculate the ages, the total ages. So yeah, this will work. Let's go and try and implement that in Python now. So, oh, I remember now, this room, we don't have idle. So I have to do Python with the online version of it, right? So it's a shame. That's okay. But I mean, you know, maybe that's good practice because maybe you don't have idle at home. I don't know. So online Python. Online Python. So the one I like is this one. So let's go and start writing our code for that. So we would write it, put our student number or whatever in there. And whatever the program is, this is the average age. And so away we go. So we can go straight from this, right? So we've got our initialization, just like that. Total ages, 0. Count. Oops. Forgot about this one. It does, you have to put a space after it. Otherwise it does crazy things like that. Count equals 0, space. Otherwise it's gonna give me, it's gonna copy down the last text that I did. Count adults. Equals 0. So again, so what we've just done there is we've initialized all of our variables. Then we're going to get the, we don't say get, do we? We say, what is the variable? It's group size. Group size takes camel case. It's not letting me do the camel case. There, it's my bad typing. Group size takes the value of, and what do we want to take the value of? Okay, so please enter the number of people in the group. So the group size is going to be equal to an input. It's just reminding us how we do that. We're going to have some text in there, and the text is just this text that we've got here. And because that's a number, we need to convert it to an integer. So we could do that just like that. And so there's our group size. Go back to our flow chart. Hopefully there's our flow chart. Got our group size. So this indicates that we've either got an if or a while. Well, we know this is a while because it's a loop, because we see the arrow coming back. So this is going to be our while condition. While what? While the count is less than the group size. So that's nice. And of course you have to have the colon. That's what. And then we're going to get the age. So again, the age is going to be one of these, we're going to have to get an input of it. How's that going to look? It's going to be a string. And if we can look at our notes, it's not exercise 2, it's exercise 3. Enter the age. It says, so I'm just going to copy that. Try to copy that. Enter the age. Or I could just type it. It's like, yeah. My cursor, I don't have fine enough control. Yeah, there we go. So I'm gonna copy that, get that. Enter the age. Now, again, this is a number, so it has to be converted to an integer. And then we can check in our, now we're gonna see if the age is bigger than 18. So, simple. Make sure that your cursor's at the right thing. Yeah. If age bigger than or equal to 18, then what do we do? So we've got this thing called count adults. We're going to add one to it. Count adults. Thank you for that. Takes the value. And, you know, you can do copy and paste. I saw students doing this a lot. Maybe it's a good idea. Because that way you don't get any problems with your having a, oh, doesn't like that. Having something typed 2 different ways. So that's all there is in that if statement. There's no else in this if statement. If you look at this, there's no else. It's just, if we do that, if it's true, we do this. Otherwise, we just continue on. So otherwise, we just skip. And then we go down to the next line. And the next line is to add that value. So total ages. And again, I might do what I'm recommending to you, which is copy the names so that we don't spell them wrong ever. If you do copy and paste, you won't spell them wrong, right? Plus age. All right. And then the other thing that we're going to do is I got the count of the adults, total ages. Yeah, just the count. So the count takes the value of count plus 1. Copy that and paste it here. Plus. So that's got us all the way down to there. The only thing now is to calculate the average. And we don't have to worry about dividing by 0. It's not possible in this program to have 0 as the denominator. And that's because we're always going to do this. If they put a group size of 0, they could say group size 0. All right, well, let's fix it so that just in case they do that. So if they said, if count is equal to 0, then the average will be equal to 0. So that's just our way of getting around that. I mean, it should be sort of standard for us now. Otherwise, we're going to calculate the average. And so the average otherwise is going to take the value of the total ages divided by the count. Total ages divided by the count. And then we just have to print it out. And they even have a way for us to do the print. So if I look at the program, the way to do the print is the average age of these members is, and the group has how many adults. Yeah, so the average age of these members is, so I'm going to copy that. I'm going to try to. Not having the cursor control here that I want. Let's type it. The average age of these members is. And now what it actually does is it puts a number there. So I'm going to add the number. So it's going to be a string. And after that, there's going to be the decimal. So yeah, I think so that's it. So this is we're going to have to convert a number to a string, and the number is going to be the average. And then the other thing we have to print is how many are adults. The group has. And so again, I'm going to have to add here. It says adults, so a space, adults in brackets with a, so there's a count here of some kind, and it's the count of adults, right? Count adults. And we'll see, does that work? Inshallah. All right, so I do have an error. Invalid syntax at line 15. Yeah, shouldn't be a colon at the end of that. Let's run it again. And enter number of people in the group. So let's try and do it like it says 2. Age of each member 17 and 21. So I'm just following this. And what does it say? No, that hasn't worked. It's not, the loop is not working. Let's go back and look at our loop. What I noticed about this, I think I had this problem before. The first time you run it, that loop doesn't work. So I don't know. Exit. Let's run it again. Let's just see. Number of people in the group 2, 17. Because I can't actually see anything wrong with that. Yeah, see no. All right, so what this is saying is that our loop is not being controlled. It's not going 2 times. So let's just check and see. Maybe we got a variable count called wrong. So group size. Okay, so that must be the same. That looks okay. Count is 0, while count is less than group size. Oh, here it is. Yeah, it was a mistake. I had a plus instead of an equal. That'll do it. Run it again. So number of people in a group, age of the first member, 17, age of the second member, 21. Yes, there we go. So the average is 19 and it has one adult. 18 adults. What? Okay, so I'm printing out the, well, that's right. Look at this. Rotten thing. So that, all right, so somehow I got a 18 on the end there when it's supposed to have a 1. And I should have a bit more space in my print. So let's, okay, so there's a couple little tweaks just to get that working. 2 people in a group. This is why we do the tests. 17 and 21. And yes, we do have 19 and there's 1 adult. Hooray. So we can do the other test, which is to do it with 6 people, 17, 21, 22, 6, 18, 25, and 14. Let's run with that, with those test values. So there's 6 people. The first one is 17 and 21, 22, 18, and 25, 14. Okay. So the average age is 19.5 and there's 4 adults. So that's working fine. Any questions on that? That's how I would do the rest of lab 10. So you end up with some code that kind of looks like that. Yeah, sorry, I don't have a big window to show it on because I don't have idle here. I'm just doing this with the online sort of thing. That's it. And it does meet with it. It is the same as our flowchart. You should include a flowchart as well. And in the window for the Python, there is a X. All right, then you got more room. Thank you. Yeah. I'm not, for some reason, I'm not able to drag that down. Okay. So that's how I do that. Let's just look at it and make sure we sort of understanding what's going on. At the start here, this is all initial values. And typically we set initial values to 0. So we got a few things that we're counting. Ages, we need the total ages to do the average, and we need the count to do the average. The other one is because we wanted to know how many people were adults. So then we go ahead. This is the thing that we use as the maximum for our count. That's fine. We put an if statement at the start. Now notice also in the loop, remember, the count is controlling the loop. And so we put the incrementing of the count as the last thing in the loop. The if statement there protects us from dividing by 0. I'll show you what I mean by that. Let's say we run the program and they, oh, it's so bad on this online thing. That let's say the number of people in the group is 0. I mean, they could do that. Then instead of the program dying on us, it just says there's 0 people and the average age is 0. Otherwise, we would have got an error. And I mean, I think it's good to try and avoid having errors. I hope that you agree with me on that. So that was lab 10. There's another lab for this week, and maybe we have time left to have a look at it, which is lab 11. So let's have a look there. Lab 11. So what's happening with lab 11? Again, it's more loops. Oh, God. All right, so introducing a new idea in this lecture, and this is the idea of modulo division. The idea of modulo division is you do the division and it's kind of the opposite of a integer division. I hope you remember that an integer division, we use 2 slashes. two divide signs, one after the other. What the integer division does is gives you the integer value of the division without the decimal part. So it truncates, we say. It removes the decimal part. Now with the modulo division, it's kind of the opposite. What we do is it's like all we care about is the decimal part, but we take it as an integer. So I'll tell you what I mean by that. So 34 divided by 7, 7 multiplied by 4 is 28, right? And 7 multiplied by 5 is 35. So 34 does not go into, 7 does not go into 34 evenly. It goes into 34 7 times with a remainder of 6. And so the value of a modular division would just be the number 6, which is the remainder. That's the remainder after the division. 12 modulo 6. 6 divides into 12 2 times. 2 times 6 is 12. And there's no remainder. So the modular division value is going to be 0. So that's how we work that. Now, the next one, 100 modular division by 12. How many times does 12 go into 100? Okay, so 8 times 12 is 96, correct? And 9 times 12 is 108. 10 times 12 is 120. So 9 times 12 is 108. 8 times 12 is 96. So if you divide 12 into 100, you get 96 with a remainder of 4, correct? 96 with a remainder of 4. 4 is the value that we say for that, because it's the remainder. When you divide 12 into 100, you're going to get 96 with a remainder of 4. The last one, 66 divided by 11. Well, 11 goes into 66 evenly, right? 6 times. And so what's the remainder? There's no remainder. So the value is going to be, the modular division is going to be 0. So that's how we do that. I hope that makes sense. And there's some more instruction, more, how you say, explanation of it there in the notes. The number 105 is evenly divisible by the number 5. Yes, 5 will go into 105 21 times with 0 remainder. And so the modular division would be 0. The integer division would be 21. But we're not interested in the integer division. We want the modular division. So we can use that to see if something divides evenly. And that's what this bit here is. We take the number and we check a modular division and see if the result is 0. If the result is 0, then we could say it's divisible by that amount. It's divisible by 5, because when we did the modular division by 5, we got 0. There's no remainder. That's all we mean for that. Okay, flowchart, pseudocode, idle. We don't have idle, but we got something like idle. So let's have a look and see if even odd, class size. Okay, class. Well, these are all kind of different. So, okay, so multiples of 5, ask the user how many numbers are divisible by 5. All right, so this is a Sentinel value loop, right? We're going to stop the loop as soon as we enter in a number which is less than 0. We're going to keep on doing it until then. And what we're going to do is we're going to add to a count, and the count will be how many numbers are evenly divisible. That's not too hard, right? So we're going to take the number. We're going to check to see if it's less than 0. If it's less than 0, we're finished. If it's not less than 0, then we're going to check to see if it's divisible by 5. If it's divisible by 5, we add 1 to our divisible by 5 counter, and we keep going. That's it. That's all there is to this program. So let's do it. It shouldn't take too long. The longest part of this is actually doing the flow chart, as you know, which is probably why you guys don't like doing flow chart, right? Anyway, so I need a new flow chart. Where's the file menu here? Oh, okay. Well, I'll just start over again then. No, seriously, I couldn't see a file menu. So this one will be divisible by 5 or something like that. Div 5, let's call it that. And it's going to be blank. I don't want this to be too painful for you. I'll try and do it as quickly as I can. divisible by 5. Of course, we're gonna have to have a start. But I think you do need to know how to do these flowcharts, so might as well just get on with it. And so we don't, we've got a loop, and the loop is going to be controlled by the value that's entered. So we have some initial values, and so one is the div5 count. Let's call it like that. So that's the thing that we're going to count, and we're going to set it equal to 0, not div4 count, div5 count. So what I'm saying with this variable is I'm saying this variable is going to keep a track of how many numbers are divisible by 5. We're going to start out with them being 0. And then the next thing we're going to do is we're going to get an input from the user to get a number. And once we got the number from the user, then we can start straight away and see if with our Sentinel loop is controlled by the number. So hopefully this is all familiar to you. Our Sentinel loop will, so is the number bigger than 0? Has to be bigger than 0, right? We're not doing averages, so, but still. Was it bigger than or equal to 0? I think it was bigger than 0. Yeah, so whatever. Actually, I think, well, let's look at the things and get it right. Negative value. So 0 is not a negative value. So we have to say bigger than or equal to 0. If we're going to get it exactly right. That's fine. So as long as the number is bigger than 0, we keep doing something. What do we keep doing? We got the number. We're going to check to see if the number is divisible by 5. And so that can be our it's going to be another one of these. And we could just say divisible by 5, or we could say num modulo 5 is equal to 0. That's another way of saying divisible by 5, right? So just, so we kind of understand what that code means. So is the modular division of 5 equal to 0? And if it is, we're going to add 1 to the count. Div5 count takes a value of div5 count plus 1. So we add 1 to the count if it's divisible by 0. And that's it. We got the number, we added, that's all. I think that's all there is. So we just go back and go back and go back. So put our arrow in there. Just it's either divisible by 0 or it's not. Make that curvy. No, that's not the one. It's this one. There we go. Okay, so what if the number is what if the number is less than 0? Then we've got our total and we just print it out. We print out the total, how many were bigger than 0. So that's going to be it's not even a calculation because the calculations are all done. We just say we print how many is bigger, sorry, it's how many are divisible by 5. It's divisible by 5, sorry. And that's it, I think. Now I'll have to double check, make sure I didn't miss anything, but I think that's it. This is a simpler program than some of the ones that we've done. Thank goodness for that, right? It's nice to have simple. Simple's good. So I think that's what it is. Let's just double check, go back to the lab and see. Multiples of 5, program will stop when the user enters a negative value. That's it. Yep, pretty much that's it. So we can now go to our online Python or whatever. somehow got away from us. And this is multiples of 5. All right, so how I like to do it is, let's just make sure that our where are you? Yeah, great. Now, for sure, I can close this, right? Yeah. Oh, there. Okay, there we go. Maybe I can close this too. I don't know. Anyway, so there it is. Start off with initializing our div count. Get the number. So getting the number, we should do it according to how they say it. Just says enter number. That's nice. So num takes the value of, so we've done this enough times so you know how this is going to be, right? And that's where I just put that. Enter the number. So now we have to start our while. Oh, there is one thing that I missed, didn't it? Oh, you guys didn't see it, right? This is a Sentinel loop that's controlled by the number, and I didn't reset the number. I'm sorry, I was doing this like it was count by account. Didn't reset the number, so I need to do this again. Sorry. That's absolutely essential. That one, it's the number that controls the loop. That's why we have to test as we go. You might be sleepy in the morning like me and just forget that. Bad. And we got it now. It's another reason why it's good to do this stuff on an, what's this? Do it on a drawing app, because so you don't have to have lots of erasures, etc. Okay, so yeah, so I had missed that out. I'm sorry, but yeah, that's necessary. It's the last thing before the loop. It's the last thing in the loop. So we got the number. This thing here is the while. Let's go there and do that. While num is bigger than or equal to 0. And what happens? Well, so here we have a if statement. If num %5, so the modular division of 5 is equal to 0, then we add 1 to the count. So I'm just going to take the count from there, copy it, paste it, add 1 to it. That's it. Nothing else in. What do we do if it's not? Oh, see, I was in a hurry there. Look, I missed a couple of things, right? So what if we do if it's not? Well, we just continue to the next one. My gosh, I was careless this morning. Can't believe I missed that. Come on, arrow. There we go. I got arrows all over the place now. I got like 10 copies of the arrow, right? Because I couldn't see it. I just kept adding them. All right. So yeah, so this is if it's true. And this is if it's false. And this is if it's true. Must have been in a hurry. I didn't finish the. Okay, so I think that's better. That's what our flow chart should look like. I'm sorry, I missed those bits at the bottom there. I missed the get number and I missed the rest of that. So if the number is, if it's, then we add up. So there's no else. So what do we do if it's not? We just go to the next line. And so what's the next line? The next line is going to be this get number. So get number, I'm not going to type it again. It's the same code as here. And that's the end of our while loop. So the next thing is just to do the print outside the while loop. We see that's outside the while loop, and that's the end of the program. Thank goodness. All right, so how do we do the print? The print says you have entered how many that are multiples of 5. So print that. Copy that page. Oh, I got the whole thing. Yeah, great. So annoying. Yeah, maybe I'll just type it. You have that's why I don't like typing it. Entered, and then there's a number, right? So this got to be a string. And how many numbers are multiples of 5? Well, that would be div 5 count. All right, so can you see any problems with that? Look, what we got is a Sentinel loop. The loop is controlled by the user, what they enter as a number. We stay in the loop as long as the number is 0 or more. When the number becomes less than 0 or more, we get out of the loop. So that's what this means. While the number is bigger than or equal to 0. If the number is divisible by 5, we add it to the divisible by 5 count. Then we get another number. Then we print out how many are divisible by 5. All right, so let's look at our notes for that. So we're going to do it 18, 15, 12, 10, 9, and -1. 18. 12. 10 and 9. Now, if I put a -1, we should get out of the loop because it's a Sentinel loop. Okay, it says we have 0. Oh, yeah. So we got another mistake. So what that means is my if statement isn't working. Let's go and see why. Again, I did this. This is the second time I've done this. I meant to type as equal and I got a plus. That'd do it. And just be careful with your typing. Try it again. 18, 15, 12. I knew I should have had that Red Bull this morning. 10, 9, and -1. We got 2 that are, okay, that's correct, but it doesn't look very nice. So we got that. I'll just put a space there. So it's, try it just one more time with the right spacing and everything. 18, 15, 12, 10, and -1. And now we have 2 values that are multiples of 5, which is correct. The multiple of 5 value is 15 and 10. Okay, so just looking back at the problem, what's the deal? We've got a Sentinel loop, and so we read the value last thing we do before entering the loop, and then we read the value again last thing inside the loop. The other added little fun that we've got is we've got an if statement inside the loop, which allows us to count only those things that meet a certain requirement. In this case, only the things that are divisible by 5. And so that's so for example, in that run that we did there, when it got to the number 15, it would have tested 15 by dividing it by 5. It would have found that the remainder was 0, so it would have added 1 to the count. And then when it got to the number 10, same. It would have gone, okay, so 10 divided by 5, well, that's 2 with no remainder. So the modular division is 0, so we add 1 to the count. And that's how we got our count of 2. And we started our count with 0 and we add to it inside the loop if they meet the condition. This is a pretty common way of doing type of problem. Even odd. So the even odd is almost the same problem. So I'm not going to do another flowchart because I'm kind of flowcharted out this morning. Is that all right? I mean, maybe later we can do that. But let's just take this problem here and save it as the even odd. The only difference between this problem and the even odd problem is the even odd problem will have an else. So this one's got an if because it only was interested in what is divisible by 5. It didn't care about the ones that weren't divisible by 5. But in the even or odd, we count the number of evens and we count the number of odds. And so we need an else. It's either one or the other, right? It's either even or it's else. So that one's nice. So I'm going to change this one. I'm going to call it even odd. It's going to be very similar, and I'm not going to draw the flowchart because I'm flowcharted out. So what I'm going to have is I'm going to have an even count. And I'm going to have, guess what's the other one going to be? Come on, guess. It's going to be a odd count. That'd be fair. So the problem in here is, as it says, we're going to read the number. We're going to count how many are even and how many are odd. Otherwise, it's the same, the negative value and all the rest of it. So what I'm going to do as my even, as my if statement, is I'm going to check the number and see if it's, when we're checking divisible, when we're checking even odd, we're going to check if it's divisible by 2, right? Are you divisible by 2? If you divide by 2 and you get a result with no remainder, then it's even. So if the number is divisible by 2, then we're going to do our even count. So I'm just going to copy my even count from here. Then my even count is going to be equal to even count plus 1. Okay, see if what I've told you, from what I've told you, you can guess what we're going to do for the else. What's going to be the else? So what if it's not divisible by 2? Then it must be odd. So in which case, the odd count will be incremented. So now we have to print how many are even and how many are odd. So it's kind of like this. So we're going to this is going to be the even count. And so I can say even numbers. So I'm just trying to do what this is saying. Then we're going to say 2 odd numbers. So let's pull this out so we can say the 2 odd numbers. So in between those, we're going to put our odd numbers. Odd count. So we could just edit that other one. It's the same problem, right? Except if it's not even, it must be odd. It's kind of like even and odd are kind of like almost Boolean, right? And so I'm treating it like Boolean. That is, if it's true that it's even, then it must be false that it's odd. Or if it's false that it's even, it must be true that it's odd. And so therefore I can use a if else. All right, let's run it and see. So according to this, we should use the numbers 18. Trying to do it here. 18, 15, 12, and 10. And 9. Oh, so it's the same numbers, right? And 9. And then we do a -1. So when we do the -1, it should have 3 even numbers and 2 odd numbers. 3 even numbers, 2 odd numbers. I'm happy with that. You happy with that? All right. So one more to do, yeah? Is the next one class size? You want to see the code again? Wish I could make it bigger. Which one? What do I do? I can make that go away. I don't know. I can make it wider. Oh yeah, that's the whole program. Even count, odd count. Now, the last problem, class size, stop the program as soon as the total number of students is more than 20. So this is a weird one. How much time do we have? We got like an hour or so. We probably should do a different flow. Oh no, let's just write the code. I'm flow charted out. So this one, I hope you got this because I'm going to change it now. And this is going to be the class size one. Class size problem. And it is similar. Enter the number of students in each section. Stop the program as soon as the total number of students is more than 20. Display the total number of students. Okay, so we're going to have a thing called total students. And of course, that's going to be 0. And we're not going to, what do we want? Oh, yeah. So instead of num, we're going to say class size. And the class size, yeah, just instead of enter number, we say class size, yeah. So we're going to read the class size, but when we get to a total of 20, then we're going to stop. We only got one total students is 0. We read the, well, it's not too tricky. Not, it's just simple in a way, I guess. So while the total students is less than or equal to 20, because as soon as we get to 20, we stop. So while the total students is less than or equal to 20, we do this, and yeah, that's it. So there's no if and else in here, I don't think. Stop the program. No more enrollments allowed. So we could, it is a Sentinel loop. So Sentinel loop has to have a read before the loop and has to have a read at the end of the loop. So this is our read. Well, I should have just copied and pasted, but you get the idea. So we're going to read it, and now we're going to add to the total students. That's it. Oh, This is nothing. This is like the simplest of all the programs so far, I guess. Maybe not. Let's see. Gonna add, oh, so equals, yeah, that's why I did it. Equals this one plus what? Plus class size. Keep making that mistake. So, okay, so we got that. Total of something students are now enrolled. At the end, we're gonna say these things. So, a total of, and then we have the total here, which is gonna be total students. I think I might, yeah, a total of total students. Are now enrolled. No more students allowed, no more enrollments allowed. Easy. No more enrollments or no more students? No more enrollments. I think that's it. So I mean, like, this is the simplest one so far. Is this right? How can it be so simple? Why are they gonna do that? Okay, let's do it. Let's see. That's what I believe it is. So just checking our values, class size of 2. Class size of 12. Class size of 16. So it hasn't got to it yet, but when it gets to 16, it should say. Nope. What have I done? Oh, don't, oh, can you believe I typed this like that? I should have copied and pasted. So I had a little S there for the class size. That messed it up because it was different than that other one. Wow, that is so bad. Anyways, let's try it again. Little things like that, they'll mess you up. What you're typing. Oh, it's still not. All right, class size equal input. Those, total of 34. So, okay, the loop is working, but not as I hoped, right? Let's see, 2, 12, 16. 12 and 16 is 28. It should have stopped then. While total students class size is less than 30, 30 students were enrolled. 2, 12. So it enrolled those. The 34 eliminated. Wouldn't allow that. It's actually kind of working. But why does it say? All right. If total students. So it is, so it was deceptive, right? If total students is bigger than 20, then we make it equal to 20. That's what they've done. So we cut it back. And yeah, okay. So that would, so we're just gonna make it less than 20. As soon as it gets to 20, it should run. Let's try again. So 2, 12, oops. Spelled it wrong. 2, 12, and 16. Yeah. I had to do one more, yeah. So I mean, it works, but I'm doing one more input because that should have stopped it. They're doing their input at the start, which is not okay. So, all right, yeah. Okay, so they're doing this differently. Let's try it the way they're doing it. What I'm gonna do is class size. I could start out with class size equals 0. And then I could take this. That way we might end up with the same loop that they've got. Let's see. Class size is 2, 12, 16. Yeah. So to get it the way, all right. So they struck. I'm sorry, I wasn't watching how I was doing the loop the way I always do it. What they've done is they didn't do. I'm not sure I agree with this way of doing it, right? Because I told you that what I like to do is I like to set the Sentinel value before entering the loop. Well, the way they've done it, you'd have to set the value to 0, and then you'd have to read it first thing inside the loop, which I really, really don't like. But that's what we've done to get the same thing that they did. Anyways, that's it. I'm going to stop recording now.